All right, what I'm gonna show you is the problem that's happening up in your attic, how to fix your AC and your heating. Now, if you ever go down to old Ybor City, they used to build houses down there. They all got flat roofs. And the reason why is because it cost a lot of money in materials, and it cost a lot of money in labor to pitch an attic up like this. So some engineer came along and said, hey, if we pitch an attic up like this, we can trap some of this 130 degrees from this 90-degree big yellow thing out here before it enters the house, make it a lot more comfortable. Now then Carrier, he came up with the condenser coil, and that's the air conditioner. And he said that we're gonna pump 50 to 55 degree air through aluminum tubes in a 130 degree attic before it enters the home. Now I'm not an engineer, but it doesn't make a lot of sense to me, but there are a lot more smarter people out there than me. Now, in the 70s, another genius engineer came along and said, hey, if we take some Pink Panther fiberglass insulation, if you guys remember those Pink Panther commercials, the do-do-do, do-do-do, all right? We're gonna put 12.5 inches, which is R38, and soak that heat up before it enters the house. Now, you only got about 5 inches right here. The whole problem with this is when your sun rises at around 7 a.m. in the east and sets around 7 p.m. in the west, you'll notice right around 9 a.m. your AC is gonna start to kick on. And it's gonna kick on and off maybe 1 to 2 times. Kick on, kick on, kick on, kick on. About 1 to 2 times. And then from 11 till about 1 o'clock, you're gonna notice it might kick on 2 to 3 times. And then the hottest time of the day, from 1 p.m. till 3 p.m., okay, right around 2 o'clock is the hottest time of the day when the sun's highest in the sky, you're gonna notice it might kick on 6 to 7 times. And then all of a sudden, when you're getting home from work, and your kids are getting home from school, and you want it the coolest in your house, you'll notice that your AC will not stop running. And it's not because it's hotter outside. It's because your insulation has given up for the day. It soaks heat up just like a sponge. And it's filling up with heat, filling up with heat, and filling up with heat. And by 1 o'clock in the afternoon, it's 130 degrees in your attic, and it's given up for the day. I want you to think of this remote like a sponge, with the green side and the yellow side with the scrubby side. And I'm gonna take this over to your faucet. And I'm gonna let it run, 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 and fill up, fill up, fill up, fill up, fill up. And once that fills up with all the heat of the water, what happens? It's gonna start to spill, start to fall. Well, the same thing happens in your attic. A lot of people tell me, well, heat rises. Well, it's absolutely true. Conduction and convection, which is thermal heat. Conduction's like a hot cup of coffee, I touch that to you, it's gonna transfer that heat that's gonna conduct the heat, or convection oven, like a convection oven. But radiant heat is always searching for the coldest place. It's the part of the light spectrum that we can feel it, but we can't see it. And if it's 95 degrees outside and it's 130 degrees in your attic, and you're keeping it at 74 in your house, where's the heat gonna go? It's gonna get forced down. So, do you guys see the problem? Let's talk about the solution. Now the solution is radiant barrier, all right? This stuff kind of looks like tinfoil, ball it up, but it's not tinfoil, all right? This was actually made by NASA in the 1950s in the form of a space blanket. It was meant for the spacesuits to keep the heat off of the astronauts and keep the heat shield on the spaceship when it's coming into the atmosphere. Now, when you get up into space, it's above 250 degrees radiant temperature on the light side of the moon. On the dark side of the moon, it's below 250 degrees, so they needed something to keep the heat in, and they needed something to keep the heat out because we don't have the atmosphere to do it. Now they needed something really lightweight because it cost about $1 million per pound to put that stuff into space back then, but they also needed something really strong because there's no going back down once you get up there, all right? Once the barrier can't be defective. So now it cost about $350 million to define this stuff back in the 50s. It's worth about $7 billion if they were gonna do it today. And what this does, it reflects 97% of the heat. It's equivalent to R184 and worth 7 feet of insulation. And how it's installed is right on your attic rafters. Now it comes in 4-foot rolls. The technical term is a double-backed Mylar 5-foil, but we have it licensed as Attic Shield. And it's gonna get stapled to your attic rafters just like this. Every 4 foot, it's gonna overlap on those attic rafters so heat can't get in and trap everything that you just did. Now it's gonna staple every 2 feet. And we're gonna leave this 4-inch air gap right in here, which allows it to reflect the heat. Now we have to leave 8 inches on the top and 8 inches on the bottom for airflow, so you get airflow from your ridge line to your soffit, because every single time you talk, every time you take a shower, every time you do the dishes, all that moisture goes right up into your attic. It's gotta have a breathability to it. So if you actually look at this stuff, there's actually some little tiny holes up there. If you look it up to the light, it's got a breathability to it. And we leave these air gaps so it can breathe, your attic can breathe. What that allows it to do is it allows some of the heat to get in. Okay, so we have to get something to pull that hot air out. Now you can use an electric attic fan, but preferably you want to use a solar attic fan, which is going to have a small panel on the top of that fan, all right, and it's going to come into your attic, and there's a temperature gauge. So when it gets above 95 degrees in your attic, it's going to right out of your attic, all right? Your attic's not going to be above 90, 95 degrees, or whatever the temperature is outside. All right, and if it's reflecting 97% of the heat, what's your insulation got to make up? 3%. It's never gonna dissipate. Your insulation warranty actually goes up to 20 years with barrier installed at the same time, because it's never gonna dissipate. It doesn't have to take the heat. Now, do you guys see the problem? You guys see the solution? All right, if you put barrier in your attic, it's gonna make it a lot more comfortable in your house. Okay, now I can send you the video.